my name's Chris and welcome to the channel. Over the last 10 years, I found that wireless dimmers can be a quick and easy solution to most of our conundrums, whether it be a table lamp center stage or a fireplace on a tracking wagon. I wanted to make a tutorial series that covered all the questions that I had when I first started using wireless dimming. This video will walk you through the setup, use, and advanced features of the RC4 wireless ecosystem. In addition to this video, there will be shorter clips that will cover specific things, such as addressing, setting IDs, and profiles. These clips are designed to give you a quick and easy access to answers while setting up a project on stage. I want to thank RC4 for their support and sponsorship of these demos. In front of us, we have a selection of RC4 wireless products. If it has a blue label, that means it operates on the 900 MHz frequency. If it has a purple label, it operates on the 2.4 GHz frequency. Here we have the DMX-Pix, which is a wireless pixel driver. We have the DMX2DIMM, which is a 2-channel dimmer. The DMX4DIMM, which is a 4-channel dimmer. The DMX4DIMM 500, which is a high output dimmer. The DMX-IO transceiver that operates on a 2.4 GHz range. And the DMX-IO transceiver that operates on the 900 MHz range. Let's break down what an RC4 wireless system is. You have to have 5 components. First, you have to have a lighting console. Without DMX data, there's no point to having wireless dimmers. Second, you'll need a transceiver, which will take the DMX data and send it out wirelessly to your devices. Third, you'll need a pixel driver or wireless dimmer, such as this DMX4DIMM, to receive that data. The fourth thing that you need is a load, such as a tungsten lamp, a solenoid, or an LED. Here we're using a daytime running light with a 3D printed bulb on top. And the last thing you need is a DC power source, such as a battery or power supply. We will be using a power supply for this project. In an age of an insane amount of wireless devices, we have to take steps to protect our data. Each RC4 wireless system has a separate set of unique private IDs to keep your data separate from other systems. Each private ID will handle one separate DMX universe. If you need multiple universes in your space, you can use multiple private IDs to allow for multiple wireless systems to operate at one time. For example, I recently designed a production of Into the Woods at the Utah Festival Opera and Musical Theater. The costume designer Mallory Peruka and I decided that we wanted to pixel map the Ugly Witch's dress to express her emotions and her magical abilities. We also had wireless pixel mapping built into our staff. In total, we needed 3 DMX universes of pixel mapping and another for regular wireless dimming. We used our 3 private IDs for the pixel mapping, plus the public ID for the wireless dimming to give us the most flexibility that we needed. This project and pixel mapping will be discussed and covered in another video. You can find the Ugly Witch video in the top corner. We also have a series of in-depth videos on how to set up and use the DMX-Pix units. When you receive an RC4 product, ID 0, ID 1, and ID 2 are your own private IDs. ID 3 is a public ID that is shared among all RC4 Series 2 and 3 products. Now, let's say a designer adds 2 more chandeliers that have to be wireless and you're out of dimmers. You call your friends across the street and ask to borrow theirs. The RC4 devices from their system will not work with your private IDs. That's the whole point of having a private ID. No one else has it. But you can set your equipment and theirs to ID 3, which is the public ID, and everything will connect at that point. Now you always want to use your own private IDs. ID 0, which is the factory default, is typically okay for most users. For the most part, when you receive your RC4 device, they're ready to go, plug and play. Most of the time, the default settings are ideal, and all you need to do is add power, DMX, and set the address. When you first power up a transceiver and dimmers, it can take up to 10 seconds to create a network. Just a reminder that devices that are intended on being used together must be on the same private ID. When you power up the devices, the currently selected ID will be indicated with a blinking pattern using the DMX data and the COP indicators. The DMX data indicator is yellow and the COP indicator is green. There are 4 different patterns to indicate the IDs. ID 0 is indicated by a rapid blink of the yellow DMX indicator. ID 1 is represented by a rapid blink of the green COP indicator. ID 2 is indicated by both the yellow and green indicators blinking together. and ID3 is indicated by the yellow and green indicators blinking alternately. As you can see, we've added a switch in line to aid in our demonstration. You can change IDs at any time by simply holding one of the set buttons on power up, and once the ID is captured, its blink pattern will appear. On power up, we can see the yellow DMX data indicator blink, which is indicating that we are currently in ID 0, which is the default ID. Now let's change the ID 1 by holding the set B button on power up. Completion, we should see the green COP indicator blinking, confirming ID 1. To select ID 2, hold the set C button on power up. You should see the yellow and green indicators blinking together, confirming that we are in ID 2. To select the public ID, ID 3, hold the D button on power up. You should see the yellow data and green COP indicators alternating, confirming that we are in ID 3, the public ID. Now let's put ourselves back into the default ID 0 by pressing Set A on power up, and we'll see the yellow DMX data indicator blink rapidly, confirming that we are back in the default ID, ID 0. Setting IDs on the DMX-IO transceiver works exactly the same way we just did on the DMX4DIMM. After the devices are powered up, the DMX data and RF Connect indicators will provide you with various information. As expected, when DMX data is present, the yellow DMX data indicator will flash. On DMX-IO transceivers, when in transmitter mode, the blue RF Connect indicator will blink slowly, showing that a wireless connection has been formed. When your DMX4DIMM is searching for a wireless connection, the RF Connect indicator remains solid and not blinking. Once it has found its connection, it will blink continuously while your dimmer is connected. A new or restored to default device will be set to a 1-to-1 addressing. DMX address 1 for dimmer A, address 2 for dimmer B, and so forth. With any new setup, before changing any settings, play with the DMX levels for these addresses to make sure your wireless dimmers work as expected. Each dimmer has an LED indicator that is connected directly to the dimmer's outputs. This will show you exactly what each dimmer is doing. We are using an ETC EOS Nomad Max setup for our tutorials. If I bring up address 1 at full, you should see dimmer A's indicator light up. If I bring up address 2, you should see the same thing for dimmer B, and so forth down the line. RC4's OneTouch makes it easy to address a dimmer quickly and on the fly. OneTouch uses the DMX address and its level to set the dimmer's addresses and parameters/dimming curves. To set the most common curves, use the levels listed. For non-dim, set your address at 100%. This is for relays, solenoids, and air valves. If you want linear, set your address at 70%. This is for incandescent lamps, halogens, and tungsten lamps. For an ISL fast, set your address at 50%. This is for when LEDs need to blink quickly and flash. It will disable the RC4 digital persistence. And then for ISL slow, you want to set your address at 30%. This is best for most LED dimming applications, which uses the RC4 digital persistence for super smooth 19-bit dimming. That's also the default setting. On the EOS system, we'll be using the command go to Q out. Don't use go to Q0 command because that only takes intensities out, but it will leave pan and tilt everything else the same. Next, we need to bring up your intended address at the level that selects your desired dimming curve. Since we are connecting LEDs, we will set the address level at 30% for an ISL slow curve. Let's say we want these LEDs to be addressed to 101 through 104. We will type into EOS address 101 at 30, enter. Then on the DMX4DIMM, we will tap the Set A button to capture the settings. Address 101 will become the DMX4DIMM starting address. When you set address A, all 4 dimmers are automatically set sequentially. Dimmer B will be address 102, dimmer C will be address 103, and dimmer D will be address 104. If you want dimmer B to be something different, let's say address 121, you would repeat the same steps that we did, but this time you would press the Set B button. So let's type into EOS, address 121, at 30, enter. We're going to tap the Set B button to capture the settings. Now dimmer B is address 121. We would repeat the same steps to set dimmers C and D. Remember, Set A assigns all 4 dimmers sequentially. If you want dimmers B, C, and D to be set differently, you have to set A first. Otherwise, setting dimmer A will overwrite B, C, and D. Now that we're addressed, let's add a load to each dimmer. Always be sure to remove power while making connections. Don't forget that wireless devices can be high current. You'll connect the common positive wire to the positive terminal. You'll connect the negative wire to the negative terminal. When connecting an RGB LED system, you would do the following. The common positive wire will connect to the positive of dimmer A. The red LED will connect to the negative of dimmer A. The green LED will connect to the negative of dimmer B, and the blue LED will connect to the negative of dimmer C. Let's take a moment to check to make sure that we wired things correctly. We will be testing a warm white and an RGB LED strip. We are going to first connect the RGB LED strip to dimmers A, B, C, and now we're going to connect the warm white LED strip to dimmer D. Now that we've connected our light sources, let's reconnect the power. We'll give the dimmer a moment here to establish a connection with the DMX-IO transceiver. So let's turn off the studio lights now so we can see what we're doing. We have our first address, which brings up the red, our second address, which will bring up our green, our next address, which brings up our blue, and finally, our next address will bring up our warm white LED tape. In another tutorial, we will look at the RC4 Commander software, available for Mac and Windows, which provides a user interface for configuration and working with advanced settings on the multiple RC4 devices remotely. A couple important things to note. The DMX4 DIMM should only be used on DC voltage and no higher than 35 volts. Doing so will severely damage the device and is extremely dangerous for the operator. Wireless dimmers are high current devices. For the DMX4 DIMM, do not exceed a total of 16 amps across all 4 dimmers. Always use a fuse or circuit breaker at the source of power, and use appropriate wire size for the fuse rating. For example, if you use a 15 amp fuse, use wire that can safely carry 15 amps. Dimmers, wireless or not, generate heat while operating. Make sure you allow space for air to move around the unit to keep it cool. Thanks for watching. If you have comments or questions, please make a comment down below. If you found this tutorial helpful, please drop a like and subscribe to the channel and stay up to date with new tutorials as they come out. Below you can find a link to RC4 Wireless where you can find more information on their products and rentals. Thanks and happy storytelling!